Good morning, good afternoon, or good evening, whether you're watching live or archived, and welcome to episode number, I am checking, 81 of the Nautel Transmission Talk Tuesday webinar series. This week, we're going to have some fun. I'm Jeff Welton, by the way, in case you haven't guessed. We're going to talk to some people smarter than me, as always, and we're going to talk about thermal imaging, taking pictures of hot stuff or cold stuff, depending on how you look at it. As I said, I got people smarter than me, reached out to the folks over at Cavell and Mertz, and I've got the president, Mr. Garrison Cavell. Gary, welcome aboard. Happy to have you back. It's been a while.
So formal. Damn. Greetings.
Hey, I didn't use your middle name, so you know you're not in trouble yet.
That's true.
And helping him out or holding him up, depending on how the situation evolves, we got Rafael Gonzalez, also with Cavell and Mertz. And Rafael, welcome.
Hello.
Oh, look at that. See, now Rafael's new to this and he's already walking in like a seasoned professional. So I think we're going to have some fun. Before we get rolling, we've got the mandatory, and I'm going to give a quick pre-shout out and y'all can hit me up in the survey after. Mark had mentioned last week, and he's got a good point. He goes, you should try to start these on time because we're engineers and punctuality is important. And he's right. And historically, Ed and I, who lean toward marketing and sales, it was like, let's try to get a round number. And when we get that round number, we'll hit the go button. So it could be a minute after, it could be 2 minutes after, but apologies for that. It was kind of been our little tradition, so I had to tell the story. Anyway, moving on. We do try to keep these fairly informal and interactive. I think everybody's wearing pants, but hey, we don't care and we don't judge. If you've got questions, comments, criticisms, concerns, there's a little place to enter them in your control window there. And if you hit those and hit the send button, it'll pop up on my screen. I'll read it out, make it part of the conversation. We'll have some fun with it. If you're not shy and you've got a microphone, you hit the little hand wavy icon and it will allow me to unmute your microphone and bring you into the conversation there as well. If you are an SBE member, remember that these webinars do qualify for half of a recertification credit under Category I. Got mine done last month, finally, after threatening to do it for several months, so I don't have to worry about it for another few years, but whatever you log that stuff in, make sure you scribble it down somewhere. All right, so on that, moving forward, of course, when you register for these, there's always a space where you can put in your advanced questions or thoughts, or like I said, it may say advanced questions. You can put anything in there at all, within reason. But this week we only had the one, and this, Gary and Rafael, we had a good conversation about this in the preamble. But is it worth getting certified? And Rafael, you put it really well. It really comes down to how legal you want to be. Not legal, but could I get you to explain it to me the way you put it?
I said legally binding, but basically it's how well would your statements hold in, let's say, the court of law? How factual, can your findings be tested? Can they be questioned? And then can you prove with unreasonable doubt that what you found is what you found?
Right. And
Well,
this was,
if you go to somebody's site and you take a bunch of thermal images and you said everything's good, nothing's going to burn down, and that night it burns down.
Yeah.
Somebody will say, well, who is this Yog and why? So the more certifications you have, the more responsible you are, the more you can be sued, I guess. But so insurance companies, if they want you to do thermography, they'll usually require a master thermographer level.
now, if you're just doing it as a Joe Blow out at the site trying to make sure you don't have a breaker panel overheat and burn the place down, then certification may be less a requirement.
Don't need
But
it.
I guess it's like everything else. Once you start doing it for other people, it becomes a much more critical sort of thing to have.
Exactly, and there's different companies that do this. I like FLIR because we have a ton of FLIR cameras, but they have a structured certification program where it's beginner level, then the next level where you get more diagnostic experience, and then the final level where you can supervise other people, write programs, write reports, and get sued. And the courses are usually a week long for the formal certification. So they're either in person, or levels 1 and 2 are in the online sometimes. But you get a lot of hands-on work with the cameras, how to choose a camera, how to operate one, how to operate the software. It's worth the time, particularly if you do a lot of this work.
Right. And at the end, when we hit the references and resources page at the very end of the webinar, I do have links up for FLIR's certification program as well. Steve's already asked, he's assuming we'll cover what it takes to get certified, and I assume basically you take the course and pass the test, and you're about there, right?
Mm-hmm.
Yep. It's like I said, 4 or 5 days, and there's lecture and there's hands-on. Here's a camera, here's different test setups with electrical equipment, energized or not. And it's, you take tests throughout each day. And at the end, there's a big test. And if you pass it, then you get a certificate right away. And if you don't, you have, I think, one chance at a retest. And then you have to go back through the course again. So they want to make sure you understand the material, the cameras, how to use them.
Right.
There's so many things that can slip you up. And in this presentation, we'll basically show you some of the things that can completely slip you.
Yeah, and I mean, it was one of those things, and I know there's some surprises. Steve's also asked if you've got a ballpark on the cost, and I mean, understanding that you don't control that, so.
Well, the FLIR, I can't speak to Fluke, but FLIR is about $2,000 a course. So it's not a cheap date, and I've gotten, I guess 3 of us here, Rafael, have been taking certification courses. Rafael and I have taken 3. I've taken 4, he's taken 3. So it's not a cheap date, but
right. But
we hold
again,
ourselves out for
depending on,
sales, so we've got to be,
right,
responsible acting.
So yeah, again, depending on your level of legal culpability, it's the more numbers you got or the more letters you got, the better off you are. So I'm also going to caveat this whole thing with almost every picture and wall of text you see in the next hour and change. Gary created it and handed it over. Rafael handed over some. I threw 1 or 2 surprises in there just because I could, but Gary did the bulk of the heavy lifting, and I want to thank you for doing that, by the way. So you did mention not all cameras are the same, and we've got a picture coming up of your test camera library. And so I reached into the archives, and anybody who's looking at the webcams, this is the entire Nautel, well, this is the entire Jeff Welton FLIR collection right here. This guy is the very original. I don't think they sold it for more than a couple of months. And then I ended up going to the iPhone platform and getting one of the newer FLIR 1 Pros, which is worked pretty well. And we'll talk in a little bit. Rafael had some good points about one versus another. But you mentioned they're not all the same. And I know, Rafael, you'd mentioned earlier that when it comes to like the FLIR 1s, the little guys, they are kind of sort of for our purposes fairly similar, yeah?
They're going to have enough information to be able to give you an accurate reading or an accurate assessment or whatever you're doing, whether you're just starting off and buy it off Amazon for $20 or actually a thermographer. Both can use a tool to its full potential, and it is enough to do the job.
The bigger the price tag, the more resolution you get, the prettier the pictures. The big takeaway here, Jeff, is if you're, and we'll get into it later about, do you want to just take some relative pictures to see what's going on, or do you really want to drill down as how hot is this thing you're looking at? Right. If you want to do some processing, you need to have something that's called radiometric. It includes, besides the JPEG picture, data as to what's behind each little pixel, what the temperature was it saw, and you can post-process that. So those kind of cameras can cost more. Most of the FLIRs, I believe, will. Rafael, would you say it's correct? The FLIR 1s and the C2s, C3s, C5s?
You have to be very careful with FLIR and every manufacturer to see if it has radiometric capabilities or it doesn't.
So the FLIR 1 basic, the $220 one does not have radiometric. The FLIR 1 Pro, which starts at $300 or $400, does, I believe. But yeah,
I've had trouble trying to find out on FLIR's website which has radiometric and which doesn't. So what I ended up using is Amazon. Go in the description, ask a question. If they say radiometric, I buy it, I test it. If it doesn't have it, I return it due to false, advertising.
Yeah, we bought something and said, oh, this is going to be cool. It's much cheaper than FLIR, and it had to return it the next day. It's like, no, this is bogus, won't work. So.
And that's a good point. As I'd say, I showed up my entire collection. Yours is a little bigger, so to speak.
There's
but
a few cameras there, yeah.
And I do see you've got one of the FLIR ones. That's the more advanced one, the FLIR 1 Pro down there to the lower left corner of the screen a little bit. But yeah, I mean, so what, just different tools for the job, basically?
Yeah.
Yes, different tools, different things. So what do you need it for? It's basically what it is. Are you looking at the same object over and over again in a mechanic shop? Are you looking at the same panel in your house? Or are you going out and doing this? How far away from an object do you have to be? That's another thing. It's, can you be close to it or you'll be vaporized instantly? That also tells you need a much better camera with a much better focus.
Right. Yeah. For example, I'm not going to look with my little FLIR 1 that goes on my cell phone. I'm probably not going to get a good visual of the power divider on an antenna 1,000 feet up in the air.
No, but you see these cameras here. You got the FLIR one. We got a 3 and a 5 little pocket ones, which are great if you're going to somebody's site and you have it in your toolbox or in your pocket. You can whip that out, and that sucker can do all the work that the bigger ones can do. You see 2 drone-mounted ones there. We also fly up and down towers and along transmission lines. And then the big guy with the pretty screen on the right, that's about a $20,000 camera, and that's for if you're doing some very serious work, or some places if you don't show up with something that looks very heavy and expensive, they don't take you seriously, so that you carry a heavy, expensive camera. It means you know what you're doing, right?
What do they say? An expert's somebody with a briefcase.
Bingo.
Yep. You've gotten quite a few pictures that sort of tell me that it's not just enough to have the fancy camera, and even the training course, what you're taking a picture of can sometimes impact what the reading looks like.
Yep. In this case here, Rafael was on a project, and that pipe, that transmission line, I guess was 9-inch. It's the same temperature, but it doesn't look like it, huh, Raf?
So that's what I wanted to ask, the viewers is, if you were flying a drone and you take a photo of this without any further knowledge, what would you assess? I would say that middle transmission line is hot. Somehow it's just hot there.
Mm-hmm.
But it's not.
It's not.
It's all the same temperature, and it can look hotter because of difference, and we'll get to later in finish and color. And it can look hot because something is actually external to the transmission line heating it.
Right. And you've heard us talking about thermal cameras, and I've done a few sessions on tools and just measurement techniques. And I mean, I'm not certified and I'm not an expert. I just happen to own one and play one on TV. Not on TV either. But one of the things I've always mentioned was that if you're taking an image of something, you need to, well, number one, and Fluke with their little point and shoot infrared, the temperature guns for years always said, shoot at the same point consistently. So, whether you use a piece of tape to set your target up or whatever, but yeah, because as you can see here just on this chunk of line at ambient, you get wildly different readings in 4 different areas.
Mm-hmm. This is a Rafael show and tell that he generated just for you, Jeff. Rafael, want to give him a quick summary where we're at?
Of course. So this is the perfect example of how radiation, or the way that cameras see radiation, can completely trick you and give you false information. And that's where having the certificate or having the experience can help you avoid these mistakes. So on this piece of copper, shiny copper, polished copper, I put an electrical tape at the very bottom, SP1, and that's my reference temperature, and I know the emissivity value of that, so I know how much radiation that piece of plastic emits, and I can then calculate it, calibrate the camera based on that one. Now, on that same piece of copper, on the top left, SP2, I spray painted with orange paint they use for marking grass, things like that. And on the top right, SP3, I sprayed it with clear UV paint. I used it for, for spraying things that are going to be the outside, so the plastic doesn't get destroyed by the UV light from the sun. All my drones are sprayed with that just to help it, again, protect it. Now, that point, SP3, is extremely important because my camera is telling me that point is hot. It's hotter by 30 degrees than supposedly the coldest spot. And then if you look at the copper piece, it's invisible. It's not there. You don't see nothing. So this can easily trick you and make you make a false assumption of that something's wrong there. Now this piece of copper is this should be complete the same temperature. I heated it and then turned off the light bulb, so it should be evenly the heat distributed. And you can kind of see the light bulb in the back right behind SP5. Now, an SP5 is also telling me is the coldest part of the temperature. That's wrong. That's actually technically the hottest part, since that's actually the part touching the light bulb. So if we normalize all the temperature equation based on the SP1, we can find the emissivity value for each of the materials, and they change completely. SP5 is 0.0005, and I couldn't even reach that number on the program. That's emissivity value. So that's 0.001% of the equation is affected. While on SP2, I had it at 0.82. So 80% of the emissivity is, used on that object. Once I normalize it, you can see the temperatures are all 142, 142, 142. But even SP5, normalizing it to 0.01, I couldn't get it to normalize. It's too shiny, and the camera just has too much trouble getting it.
So that's the takeaway, is shiny stuff will lie to you a lot. And again, two things to look at. Am I looking at this to see I may have a problem? It's sort of a relative, or I call it qualitative. Or do I really want to measure the temperature? That's quantitative. Doing a temperature measurement with an IR camera is a big, hairy deal. You've got to account for this emissivity that Rafael's talking about, reflections, wind, humidity. There's a lot of stuff that goes into it. And for the 90% of what people are doing in transmitters sites and in most places in an industrial plant, you don't need to come up with an exact number unless you really have an insurance reason for it, or you want to track something over time.
Yeah,
So
what you're looking at is more of, this is a whole lot hotter than everything else.
Right.
Or
And
a lot hotter than it was last month.
by the way, Scotch, I forgot the number of the Scotch black electrical tape, but that is a wonderful reference point, and all thermographers use it because it has an emissivity of 0.95. If you take the temperature at that electrical tape and then you see what it is, you said it's emissivity, then you can go to all the other spots you're worried about, dial those temperatures in until they equal what the black tape said, boom, that's your emissivity value, you write that down. So again, it's a week-long course to get all this straight, but the point is, if something is shiny or it's dull or it's black or it's painted, it may show up different and lie to what its actual temperature is. Don't get worried about the weeds.
And looking at the piece of copper in the center, you can see I bent it like a pipe, and you can kind of see the reflection of, those mirrors in the fun houses that they bend. And you can't see my reflection on the copper because it's too dull, but you can kind of see the same reflection on the thermal, and you see the line going straight from the top to bottom.
Yep.
That's my heat signature on the actual copper as well.
Yeah. Now, I had a guy who sent his regrets that said he couldn't attend, but he's got some interest in this too. And he'd mentioned the rolls of black electrical tape of variety sizes up to at least 2 inches wide for wrapping around for that. Now, I would have thought, and here's a question, and maybe a dumb question because I specialize in those. I would have thought like a cloth tape, a non-reflective tape would have given you a better result.
Probably would.
It's all a matter of getting a reference. Once you have a known reference, you can use it. The black electro tape, a number is the one that's already been classified. We can use it, but if you can use anything you want really, as long as you can get the emissivity value of that object.
See, and this is just the Canadian. We've always got hockey tape, so cloth electric or cloth black tape's always in my toolkit.
Again,
and if you don't,
if you have a dark car, a black car, and you sit in it in a summer, you get hot as hell. So black is emissivity of 1 is perfect. It means it radiates equally well, it absorbs equally well, better than anything. Below 1, it gets, I'll use a technical term, crappier and crappier, and tends to reflect more and not radiate.
Yeah.
So that's where you get the differences. So emissivity 1 is a perfect black body.
Cool. All right, moving ahead. This comes back to, and this is where we were talking about the qualitative versus quantitative. Do you need a number or do you need a reference?
Right. And for most of what we do in the business, even when I'm doing the transmission line and antenna inspections, sometimes the environment won't let you do the emissivity and get everything dialed in so you get a perfect number. So you just look at relative differences. So I call that qualitative. That's usually good enough to see what's going on. And if you think, gee, here's where you use common sense. Does that make sense what I'm seeing? Let me change the camera position. Let me look at a different section. That's again, just kind of looking at the pretty colors, does that make sense? Does that look hot? And then you can take secondary means like a thermometer or a pyrometer, the little laser dot pointer thing, or a thermocouple, and attach it to the device, providing it's not got too much energy,
Right.
like a power line.
And I mean, it's like one of those, I took a picture of my dog with my FLIR, and of course it showed his nose as a cold, dark spot, and the rest of him is marginally warmer, depending on where you were. But we did not bother doing any emissivity testing. Yeah.
A lot of medicine uses this because you can see warm spots on a body and see if there's some people even can trace cancer, external cancer with it. So it's kind of interesting.
When you have tense muscles, muscle pain, the muscle tends to contract and generates heat in the process.
Yeah, inflammation. Sure, that makes sense. So now moving ahead, here's another example of what you were talking with the reflectivity and the reflections. And this one, you can see you with the camera.
Nope, that's me holding the camera, taking a photo inside the transmitter.
Yeah, this is the side of an RCA tube type transmitter. It was hotter than the hinges of hell in there. In spite of that, you can see, because of the surface he's looking at, his perfect reflection. When we took that picture, took it back to the lab and said, look at that shit. So that's that's
well, and it's like in the warm up, I was saying, I walked up in front of one of our newer transmitters not too long ago and took a picture with the IR camera just at the front, looking at the front panel with the panel doors closed. And I got a perfect reflection measuring my own skin temperature in the touchscreen. So I was looking at me. It was basically like an IR mirror almost.
What that tells you, though, Jeff, is that whether you're, no matter what method you're using, if you're standing in front of something and the temperature doesn't, it looks hot, but it doesn't make sense, move your position. Maybe it's either coming from you or something else in the room that's reflecting heat onto the surface.
Whenever you find a heat anomaly, change the angle. 3 degrees, 5 degrees, you know, you just keep changing it. Is it still there? Is it not? Because radiation is very wacky.
Right, and it comes also down to one of the things that we had discussed a little bit in the pre-show, if you will. But we talk a lot about emissivity and reflectivity, but there's also transmissivity. You can't take a picture through a window, for example, because the window doesn't transmit IR well.
That's right. You're not going to catch your significant other in a car taking a picture of her and somebody. You know, it's like.
And the crazy part is that equation changes as the wavelength changes.
It's true.
So it's just even crazier.
Yeah, these are long wave cameras. The medium wave cameras can see more stuff and can look through glass and certain other objects. So it depends on the wavelength of the camera. And the fancier cameras go to a higher wavelength and cost many dB dollars more.
And that kind of ties into so FLIR has this Delta program, which is basically a drone course. But in that program, they've got a series of white papers, and you sent me a couple of them. So being curious and inquisitive and having Google, I got on FLIR's website and actually found that they do make those available for public access. So we've got those linked at the end too, and that's where I picked up on the transmissivity. Because that's one of those things, you know, you always think, oh, you can take an IR picture through a window, and you really can't. You can take a UV picture through a window.
You also, the FLIR side has a lot of short courses, 1 hour courses, 5-minute courses. Just if you say, gee, what's emissivity? You see these little snippets, YouTube snippets, and they're great.
Actually, I think their whole entire course is on YouTube, if you look hard enough.
So this was the one, and this threw me a lot. And we'll qualify it a little further on, but there's a lot of different things, and most of it we've mentioned already. But letter C, wind. I never really thought about wind having an impact, and you've told me that wind is a significant impact if you're taking an outdoor reading.
Yeah, or even indoor if you got an air conditioner running and it turns off, turns on, a fan that oscillates. What's it, Rafael? 30–40% change in temperature as measured. So it's kind of look at your environment, what's going on. It tells you a whole lot. Lots of little things. It's just, again, with VNAs, network analyzers, there's a whole lot of ways to screw yourself up. Same with this tool. It's, you know, get one of the cheap ones, look at the FLIR and Fluke and other sites and play with it and experiment with it and see what's going on in your own house, for example. You'll see that GFCI outlets. They're hot because they have a low power supply.
Well, and one of the cool things I've used my little guy for, of course, we're way up in the Great White North, and it is actually white at the moment. It hadn't had a lot of snow until the past couple of weeks. But I walked around the basement and taking pictures of the basement walls to see where I'm losing heat. Looking around doors and windows, things like that. And again, I'm not looking for an exact reading, but if I look at a door and it's all yellow except the lower edge is blue, I know I need to replace the draft stopper.
Yep, I look up towards the ceiling where the wall meets the ceiling. You can see where the insulation might have been pulled back and you're losing heat.
So for what it's worth, I went through and redid all that after we re-roofed the house and discovered ice dams the following year. And anyway, so I took a picture of where the walls meet the ceiling in the recently renovated living room, and it's all uniform. And it's like, yay, they did it right. But yeah, I mean, it's just stuff like that that I hadn't really thought about over and above. I mean, it's like I said, I've always sort of promoted these things as being an excellent tool. You walk in, you take a picture of the circuit breaker panel. You can tell if you got a hot breaker, yay, hoo, yay. But there are so many other things that that they're useful for as well.
Oh, absolutely. It's a lot of fun you can trace where a hot water pipe is running in your house. Oh, this is a Rafael special. We got called out to an AM station and their pattern was AFU, which is a technical term. And, we could take out all our fancy test gear, but Rafael went out with the FLIR camera and took a look around the phaser, and he found this capacitor here living in sin. And it's running a typically hotter, like 190 degrees in round numbers, as opposed to ambient, which was like 88 degrees. And what we have here is different color presentations. In your cameras, you can dial in different, what they call them, palettes. Sometimes black and white, sometimes iron bow. That's a pretty one on the right. Everybody likes that. It looks pretty cool. Sometimes like the one on the lower left, that shows where the failure is much more precisely. So go through the available color palettes and see which tells you the information more clearly. It's kind of a cool way to do it. You can even set little temperature thresholds. They call them alarms. What's the other name for that, Rafael? Do you remember?
Isotherm. And there's two things to distinguish between a live operating palette, which is the one you're going to be using during live operation, and then your analyzing palette. Your analyzing palette is all your palettes. You shouldn't just pick one or two. It's highly recommended that you open up the picture and swap through palettes, kind of like a predator vision. Swap through each and every single palette, because one of them might be hiding artifacts or something that other ones may not be able to grab. So just quickly switch through photos, 1, 2, 3, 4, 5, and see if anything looks odd. But definitely look through every palette available.
Now, can you take the picture and then swap palettes after, or do you have to do it while you're aiming the camera? So you can do it after the fact.
Correct. The palette just takes the metadata and then presents it to you how you like.
Okay, I'm going to put Rafael on the spot because I'm good at that. There's only 4 things you really can't fix in post-processing. That's distance, focus. What were the other 2?
Distance, focus, spot ratio. That's
I
and
forgot the other one, but yeah. So there's a lot you can do in software. Some things, you can't force it to do something that's not there, like focus or how far away you were.
Right.
The metadata can't change.
Yeah. If you don't give it the tools it needs to do the job, it's not going to be able to do anything with it. Understood.
For those folks who are looking to get a precise temperature, you got to make sure the little reticule, the gun sight in the camera, is filled up with the area you want to measure. If it falls out of that area, you're going to get a dispersed temperature reading. The information is not hitting on enough of the pixels. You want to hit all the pixels in the middle. It's like a 4x4, 8x8.
It takes an average of all the pictures inside the circle, and that's how it calculates it.
So that's sort of a pro tip. The next slide is kind of cool. I saw you sneak it in there. And again, what are you looking at? Oh my God, this breaker has a problem. It's a loose connection in that center phase. So it heats up. You can see the hot white in the center, and you can see it's also heating up the cable going to it. Right. So you turn off the power and see if the simple tightening will do it, or if the thing is toast and it's gotten too hot.
So now, there we go. Brian's made a comment that beekeepers will also use infrared to find out where hives may be hidden in your building to see more exactly where the hive is in order to get it out.
Oh
Absolutely.
yeah, they're gonna be nice, 90 degrees toasty.
Yeah. So that's a good one. Thanks, Brian. And the other thing that's important to remember on this, and I've taken, I should have put it up in here as a slide and I forgot, but I've got two breaker panel pictures, both showing relatively, I tend to use a yellow red spectrum just because that's the one that gets my attention the most. But it shows them both looking the same number, same amount of off color, but I've got the intensity levels dialed back on one. So one's actually measuring 100 degrees and one's measuring 190 degrees. So,
Range is important. It can make it look much worse and much better.
so yeah, so the settings you use, it's like every other tool. You got to play with it enough to get used to what it does and how it reacts on known instances before you start hitting it with the unknown.
Yeah.
Cool. Let's see, you got a few more pictures of hot wires in here, or
But this
hotter
one is
wires.
different because it's not the connection that's bad. It's that somebody was trying to make up for, I guess, a bad budget and could not put the right kind of cable in there. So they tried to parallel stuff up. But
Hey,
those,
two little wires is just as good as one big wire, right?
exactly, and you're exceeding the ampacity rating or the temperature rating for that wire. So that's not a good thing. You need to put in the correct size wire. And it's, again, you look at the connections, they're not hot. The wires are hot. So
Yep.
again, what do you blame it on? You blame it on that, in that case, the wire.
Mm-hmm. Let's see. William threw this in here, and he asked if I could do it at the end of the webinar, but I'm going to do it now, and that way, if I've forgotten to do it at the end, then we're covered. But he says I never listened to. This is a problem when you got people that are used to the question interface and can type faster than I can think, but which doesn't take much. Toward the end of this webinar, if you can make a suggestion as to a relatively inexpensive model to keep in a toolkit for general occasional use, I'd very much appreciate it. I mean, of course, for me, it's this one.
I would recommend the C2.
Who's that?
C2.
The FLIR C2. Reason why, it's older model. You can get them used. They're handheld, has a screen on it, so you don't have to worry about the operating system on the phone, updates on the phone. It's a standalone unit. You charge it, it works. Done. And you can get a cheap model, less than $200 for the C2, about $500 for the C5. They're standalone. They're as big as this. I can go pick it up from the closet. They're about this size, and it'll give you everything you need.
Exactly. So the C2, C3, C5, any of that generation, it fits in your shirt pocket. It's pretty cool.
It's
and again,
radiometric, so
yeah,
you can't analyze it. That's one of the key things.
Very cool. So there, you heard it here first. I got another wall of text coming up, so I'll let Gary deal with this one.
Oh my God.
And this again talks about the wind. Hey, you wrote it, you read it.
Oh, okay. That's my PowerPoint. No, it's just, again, how well an object is telling you its temperature depends on the color of it, its finish, the material. And we went through this, anything reflecting onto it. The angle, if you look at it from too sharp of an angle, it'll lie to you about the temperature. Wind speed, I mean, 30 to 40% difference. Thermal loading, I mentioned, if you have an air conditioner that turns on and turns off. Rafael was on the job site and he sent me a shot. I said, look at this, it's hot. I said, yeah, look beyond it. There's a heating unit, exhaust blowing on the device. Oh yeah, shit. And then, so that's the kind of, you look for what else could be loading your device. Are you near a heater? Well, of course, the thing next to it will be hot. But G is the big one. You know, take a look at it. Does it make sense? Does it make sense that thing you're looking at should be hot? Is it the environment? Is it just normal? What's normal for that piece of equipment?
Right. Yeah, and I mean, you know, there are some things in that flasher unit I showed before with the hot spot on the circuit board. Well, that hot spot was a voltage regulator. I expected something that's bolted to a heatsink to be a little toastier, or it wouldn't have been bolted to a heatsink.
And that's where you take a picture a week later, a month later, and is it the same? If it's staying the same, it's probably normal, unless you can find a manufacturer spec for it, then which is hard to find, manufacturer. So make sure we know what's normal for your stuff.
Those shifty characters.
That's right.
But the other thing too to think about is not just when you take the reference, and this is where it comes down to know your instrument. You've got to know your instrument well enough to know that when you take the picture a month later, you've got your settings exactly the same as you had them the first time.
One other point, I've seen it happen with these little point and shoot cat toy alias thermal guns, but also with some of the thermal cameras. If you're like us, we play in the back of RF equipment with the doors off, and of course, following all the OSHA rules. And sometimes the RF gets into the camera and can make the camera do oddball things, including give you bad readings. So if you're at the business end of a coil and you go to one side of the coil, like, oh, I guess I was in a magnetic field. Well, that's good for me. But, you know, think about the environment. If you're in a high RF environment, it may be toasted.
Right. And I mean, that's one of the reasons that, you know, if you're working on a tube transmitter, for example, and you need to measure plate voltage, you're probably using a Simpson 260 over a Fluke 77 because some things just don't play well with RF.
Yep.
You know, that we discovered a little side note, because it's no fun if we can't wander off the reservation once or twice, but I also discovered that if you used your Fluke 77 in a high RF environment and had a capacitor across the terminals on the meter leads to decouple it so you could actually work in that RF environment, it's a good idea not to put it across 600 volts AC immediately after until you've removed the capacitor.
Boom.
Yeah, that was highly spectacular.
I had to get boom in there, man.
If you didn't, you knew I was going to. But yeah, I mean, it's just like you say, a lot of it is common sense, and a lot of it comes down to familiarity with your gear. And so this is an interesting picture. I mean, we've all seen the pole pigs out on the telephone poles, or power poles. So what are we looking at here specifically?
One of the phases coming off that pole pig is an unhappy camper. And I was at somebody's transmitter site walking around, and I always have a little camera with me. And I, just for the fun of it, I just started looking at the power pig and said, holy shit, which is, again, a technical term, and get through the utility company and try to get to an engineer at the utility company and say, hey, you got phase so-and-so and this pole number so-and-so, transformer this. How do you know? I got a thermal camera. Oh, and this is at a major radio station in a major market, and that was about to be a problem. So look around. The other thing on power poles, you'll see things that look like insulators. Some of those things that look like insulators are actually surge arresters, and they can over time get kind of crispy, and they will actually explode. They're kind of not nice to be around. So those things look like they're heating up. Anything looks like an insulator on a power station that's heating up, probably going to go boom soon. So you try to get somebody's attention.
And as always, we try to get the stuff that goes boom before it goes boom. But sometimes
not as entertaining, but it's better to do it.
Well, you know, it makes better YouTube if you can get it while it's going boom, but it doesn't help the station revenue nearly as well. The other thing you've got, so picture of a breaker. Well, breaker box. So you started with a hot spot in a breaker box.
Yeah, that's not normal. And it wasn't a reflection. And then actually, because it wasn't a horribly huge circuit, I could touch it and say, yep, the skin doesn't lie. That sucker's warm. And open up the box very carefully. In this case, it wasn't going to be an arc flash problem because of the magnitude of the voltage. And yeah, that switch is an unhappy camper, and it needs to be replaced, which they fought because it would cost money and take them off the air. I said, okay, well.
You're off the air a lot longer if it burns up.
Again, that's why walking into a plant and just being a doofus looking around, you know, to use your camera, be a geek. Gee, that's pretty cool. And take notes. Gee, that looks hot. I wonder if it is always. If you don't have a rating, then just, okay, I know that this cabinet was hot and this breaker looks kind of warm. But yeah, white hot is a bad thing usually.
Typically, yeah. And I mean, that's one of those, you know, you always used to see the old timers walk in and just run the back of their hand down the breaker panel looking for warm spots.
Yep.
And this way you can, you know, you get out of the car, you can be loading your camera up or grabbing your camera, getting it powered up. You walk in the door and you're ready to point, shoot, and you've got your breakers all averaged out right immediately.
Yep.
Now, this is one that came in from a customer. Brad in Nebraska sent it in a little while ago. And again, I don't take the number as a quantitative amount, but that breaker, that pole looks a lot hotter than the other two. And so they went from power stability problems to no power stability problems.
Yep.
You know, just as a result of that picture. And I put the text in there just because I get the little pat in the back for talking them into buying the FLIR camera to begin with. So there you go.
There you go. Yeah, it's amazing what you can find just looking around.
And again, it's one of these things that their issue was with stability. They just had one leg that didn't appear to be, and they were, as I recall, because we had a conversation, but I want to say it was related to they thought it was related to a hot leg or like something going open and like an open delta, but they had tree transformers and everything, and so yep, that's what he found. Now, of course, and we should have talked safety before I put the AC power pictures up, but because hindsight's 2020 and because I'm trying to space out the walls of text a little bit, safety is really critical when you start messing with power panels.
It's if you've ever seen an arc flash explosion video, it's pretty frightening stuff. And you can, even if you're properly clothed and have all the stuff on, the force from an arc flash from a big panel can kill you just from the
Concussion. Yep.
And a lot of the protective stuff sometimes gets burned into the skin. I mean, that's a lot of power, a lot of heat, a lot of energy. So when I'm doing a power plant sort of thing, I get somebody experienced, for real electrician, somebody else as a safety officer, and I stand where I'm told to stand, and I don't move, and I don't do anything without permission. Now, some of these panels have IR viewing ports, and you got to that's a whole nother topic, but there's little trap doors that have a special kind of viewing glass that's friendly to IR, and you can view through there. But again, if you're looking for an exact number, you need to compensate for the thermal properties of the glass and how transmissive it is and all the happy stuff. But again, some of these where they know you need to look at it repeatedly, they'll put in an IR viewing port. And that's pretty handy stuff. Otherwise,
it's worth noting too on arc flash. I've had a lot of guys say, well, we don't work on anything that would require arc flash. And 125 kVA is the nominal threshold by OSHA. If it's above 125 kVA, well, if you've got take a 480 volt entrance, 480 volts, you don't need a lot of amps to get above 125 kVA. About 30 will do it. So, again, this is, did I get that math right? I think I got that math right. Might be 300. Come on, Gary, do the math. I can see the brains, I can see the wheels spinning, but.
I just want some more coffee. But again, be careful when you open up a panel, or I know people don't want to pay for electricians, but get an electrician to go with you. And if he says, no, stand back, do what he says, because it's heck with the radio station. Your health is important.
I like to treat every place that I visit like a gentleman's club. I can look, but I can't touch, because if one mistake, my curiosity has me looking at everything. But if I make one mistake, I touch something and it's electrified, I can just vaporize my arm or myself. It's not worth it. I have my camera that can do that.
Well, that's when you get right down to it, that's the whole purpose of the IR cameras, is to be able to take these pictures at a distance, as opposed to getting right in there with both hands in a multimeter.
And so, you can, Jeff, we give you Rafael's line about the gentleman's club if you need to use it in a NUG session.
NUG's, holy smokes, less than a month and a half away.
Right.
You may see it there. So, yep. William says what happens at Cavell Mertz stays at Cavell Mertz.
Exactly.
So Gary's wife is logged in, so she's probably sitting here taking notes for the postmortem conversation on this.
I'm in trouble. Trouble.
That's it. It's all over now. But and here's another prime example. So I'd say we've talked about electrical stuff, and we've talked about various other things, but elbows are another place where you'll see split bullets or O-rings that are left out, and things will tend to get toasty.
They're also, Rafael's actually a mechanical engineer by training, so he's handy to have around for stuff like this. But yeah, elbows take a lot of stress from push and pull from what's connected to them. Elbows are usually the things that are living in sin at a transmitter site. Over time, they'll get into trouble and they'll gleefully shed copper and start to make things happen, and it'll be a boom event for you. Yep. So yeah, this one was definitely hot. We said, hey, you need to change that. And of course, you have the usual argument, and we're going to be off the air and it'll cost money. So, okay, fine. Well, here's the data. Have a nice day.
William asked the same question I asked, asked myself, because counting the bolts. What size line is that?
That one I think was 9-inch, 9 or 7, something big and nasty at a TV station that was in trouble. And you can see there, Jeff, you pointed this out earlier, that's I think the MIAT label in the center of the yellow part. So that elbow is in trouble.
And that's the kind of thing you want to find out well before it fails, because those failures, well, number one, that's a 300-pound chunk of brass at a guess if it's 7 or 9 inch.
Yeah, look at all the bolts on that sucker. You know, that's a big piece of iron.
It's not a nickel 95 either. So, and there's another example. Is that the same one looking up the tower?
No, that's a different one.
Oh, look at that.
Yeah, and it's right in that corner for some reason. It was the push and pull over the years, and that a bullet was working loose and pushing something closer, and it started to arc. And gee, let's investigate that.
Mm-hmm. But I mean, that's one of those things that you can find this stuff from a distance. Again, you can find a lot of it from the ground without having to get the tower climbers out until you've got an idea there's something to actually look for.
Exactly. This one's kind of interesting. Look at that, the vertical run from the ground going up, and then there's a flange, and the vertical run is really not so much uppy down there, kind of tilts to the right because it's been pulled. Yep. What do you think's happening below that? It's the connection on the inside is saying, I don't like being pushed and pulled and pushed and pulled. And I had an argument with the involved engineer, like, you better look at that like soon. No, that's all bullshit. It's, He didn't believe in thermal. And he went off the air a month later.
Now I'm looking about half wave down from that. I see a hot spot right below the coupling below it too, or it looks like.
You will. That's an interesting point. Good, glad you raised that. As you can see, if there's a bad spot, you can often see, I guess every half wave point, you can see little hot spots into attenuation winds out. In the ancient days of AM, when we had outside transmission lines, you could see melted spots in the snow when there was a reflective power problem down the transmission line. The same sort of thing. You can catch the temperature cycles.
So this is the part where we tell the side note about where we met in the basement at American University station. American University?
It was some private AM station in the Washington, D.C. area where we were trying to fit 10 pounds of stuff in a 5-pound bag down some stairs, and you were an unhappy camper.
I don't think I used all the words then. Of course, I was fairly new at field service. I probably didn't know all the words then. I've been educated.
All the sailor words.
But yeah, so that's how far back we go, and that's a long distance. So another place you use this, we were talking about AM, ATUs.
Yep. Look at this puppy here. I mean, the stuff on the bottom looks kind of warm, but it's actually okay. I mean, some of that's the reflectivity, some of it is warmth. It gets warmer naturally. You can see the coil in the upper left, that's a little warmer because it's in the circuit. But that contactor on the upper right, it's not a happy camper. And I think the connection down below where the 220 comes in, it's not happy either. So it's handy for finding, gee, that thing's going to either give out, or we need to change the contacts or tighten them up or clean them.
Right. And like you say, I mean, some of these phasers and tuning units are built on aluminum backplanes, so the reflectivity can factor in quite a bit, but changing your angle, and if you see something like a really hot spot on a contactor arm, that's kind of a giveaway right there.
Yep. It's kind of cool.
Yeah. And then, I mean, this is hollow state technology. I don't know anything about glass FETs, so you'll have to tell this one.
This was, to show the age of it, it was a klystron tube in a TV transmitter in a major market. And it was water cooled. Well, the water level was down. And that was like a $250,000 thing about to go wrong. So we're just kind of walking around, fat, dumb, and happy, and kind of playing with our camera and say, oh, look at that. Is that normal? Shouldn't the water be higher? Oh, shit. And then we did some things.
And that's one of the really big goals about these things. I mean, it's like, say, a couple $100, give or take, but it's the goal is to save you from having the high-end repairs, or to know about them so you can schedule it at your convenience, not the equipment's convenience.
And it wasn't that I was so damn smart about the klystron tube, although I was a TV chief 1,000 years ago. It's just I had another cabinet with another tube. It looked different. So I asked the guy who knew what was going on, the TV chief, said, I'm seeing something here and something there. Is that water level? Oh, yeah. Oh, hell, that one looks like it's down. And he read some gauge and said, yep, that one's low. Thanks for spotting that. So I didn't know nothing, but I knew something was different.
Right. And that's what you were saying before. It's like common sense. And does this look right?
Yeah.
So you talked earlier about drone mounting systems, and you were saying that you guys at Cavell Mertz do have some drones, and of course, as you said, a couple of certified thermographers. So you obviously do this stuff for a living. But there's some things to think about, like we said, with the wind, but other things too to think about with drone work.
Yeah, well, I want to back up just for a second, not on the slides, just in the thoughts, is the little C5, C2s, all those will, up to maybe 30 feet, Rafael, something like that. If you want to have a long distance lens, you have to pay more money for the long distance lens, and maybe want to get a liquid nitrogen cooled camera with even the longer lens. That's about $150,000. So you don't need to buy a drone. You can just rent, lease, or buy a bigger camera with a longer lens length, and you can still see things from the ground. Mm-hmm. We said that's a lot of US dollars, so we overspent on drones instead. So that way Rafael has a job. And we have a DJI, and we have another couple of drones that have FLIR cameras on them. DJI software, radiometric software, is different from FLIR, so you're kind of stuck using DJI's software. It is sort of about the same, isn't it, Rafael? I mean, it's
identical.
Yeah,
same technologies.
But you can't take the DJI image and put it into a FLIR analysis program, or vice versa. They'll call you bad words.
The metadata on both images are locked to their own software. But technology-wise, they're identical.
But anyway, if you need to go up a tower and look at stuff like we are tasked to do, looking at an antenna, looking at transmission line, you can get up close and personal with a drone and taking thermal readings. But you don't want to do this in the middle of the day when the sun's shining on it, because you're fighting against the sun, which is lots of degrees Kelvin compared to the system. So you want to wait until after dark, which means you have to be certified to fly at night, and you have to wait enough after dark to where the thermal loading, so that it's like the pot on the stove. You turn off the stove, it'll be cool. No, wait for it to cool down. Right. Wait for ambient temperature to cool it down. So now you're looking at the transmission lines running, but not the sun's impact is running. So solar loading is something that will make you miss a fault on a line. So do it at night, do it first thing in the morning.
It'll mask issues.
Yep.
And light is such an important factor that is not just the heat from the light. If the sun is setting and there's still light touching the tower, it'll show up as radiation on your camera. It just get rid of all the variables that you can, so you can get down to the real data.
Well, and over and above that, I'm assuming that if you go in after sunset, for example, I mean, just like the pot, if I take my copper pot versus my cast iron, they're going to cool down at different rates.
Yep. And it's interesting, we'll cover it elsewhere, but mechanical stress can show up thermally. So you might see, we did a recent case where we saw that one leg of the tower was warmer, and there's no electricity in it, but it was just flat hotter because of the way the tower was stressed. We mentioned it to a tower climber, and they checked out and did some guy wire retentioning. So it's silly stuff that you'll see like that. But again, for the most of what we do, when somebody's paying us dollars to look at a TV antenna or FM antenna or transmission line, we don't try to give you an exact reading. We use the qualitative. Gee, does that look hot at that junction?
Right, and that comes on to this one.
Go ahead, Rafael.
So even though we do take like a less direct approach to trying to get the temperature, I still need to take into account lots of variables. Like I said, wind can be up to 40%. Yes, but it's also dynamic. Is the wind 1 meter per second in the bottom and then 15 at the very top? That means my equation needs to be variable from zero, from the ground to the very top. Altitude, as I get higher and higher, I also drop in temperature. My ambient temperature drops. So my equation now has a dynamic, wind, dynamic elevation, and then you start adding all these things, and the equations can become very, very
complex.
Correct, and then you then start burning more time and effort into trying to get that than just kind of stepping back and just seeing it as a broad.
Yeah, just look at the relative colors. See, that doesn't look right, as opposed to trying to do the math, because it doesn't matter. Something's wrong. This was taken with a liquid nitrogen shortwave camera on the ground, looking at something 1,000 feet up. So if you're willing to pay the money, we rented this puppy at that time because we didn't have drones back when this was taken. This is a center-fed antenna, and in the middle, it's not happy.
Right.
And when we're able to get close enough to it, you can see on the right, that's a picture of burned radomes. That's often a bad sign. And you took off the elbow connector at the bottom, and there was about 5 gallons of soot. So you put all this together, and it's like, gee, that antenna has problems, and you need to replace it. And of course, the customer argues with you about it. But and then 3 weeks later, they were off the air because the antenna decided. But we could spot this. This all happened because I was seeing funny artifacts in the video back in the analog days, and funny jumps in the VisWar. So something was unhappy, and it was trying to tell you, hey, I'm in trouble. And we were called out to do a network analyzer. Here's the thing, network analyzer is wonderful to sweep with, but it's like doing something under load. Network analyzer uses a few milliwatts maybe. It won't see a lot of that stuff. You need to have something under load operating.
Right.
Same with your power readings, and you go in and you're looking at power panels. Make sure they're operating under normal load. If they're not operating under normal load, today you walk in, everything's fine. Next week you walk in and all of a sudden the phase looks hot. Well, that's because the air conditioner was running on that phase that day. So again, pay attention.
Right. It's not just the device, it's the things around the device.
Yeah.
You were talking about the stress earlier and mechanical stress, and this is an example of that, I believe.
Yep, that's an old push-pull base insulator. It's something that used to be called KQV in Pittsburgh. Nothing on anywhere near it. The array was energized, and I'm sitting here looking at this with a thermal camera saying, why is that insulator hot? And it was just thermal stress in that particular leg, and it was the base was tilted in a funny way, and it was getting a lot of pressure. So you can see this in guy wires, for example, near insulators. You'll see where there's a bit of stress. So what is normal? In this case, that was okay enough. It's been operating that way for 70 years. It's probably okay. So again, qualify what you're looking at. Gee, that's different. I haven't seen that before. Let's just watch it.
Yeah. So yeah, like I say, this looks different. Does it look different than this next time I look?
Yeah.
So that's a good point. We are tagged up at the top of the hour. We've still got a few bits to go, so anybody who has to leave can leave. You can catch it on the archive. Otherwise, we'll just carry on if you guys get a couple more minutes. If you don't, well, you can leave and I'll carry on myself, but it won't be nearly as entertaining.
Thanks for joining us.
So yeah, and that comes back to what's normal, and this was an example of that.
Yeah, the motor on the upper left, that's normal. Good thing is most motors have a nameplate on it, and they'll tell you operating temperature. It's usually in Canadian units. That's why they have C on it. But you can do the math.
Well,
but yeah,
that's because if you want to do it in American, you'd have to use a banana for scale.
Exactly. Sucker. But we do it in Kelvin. That's even more fun. But yeah,
I told somebody I'm bilingual. I speak English and American.
There you go. But again, you look at the right, yeah, you expect to see some heat coming through the vents on the right. If that was clogged up, it would look different thermally. So that's a normal appearance for that particular motor. Lower left, that's a TV transmitter with a whole bunch of liquid cooling pumps. And that's normal. Again, looking at the motor ratings. And again, you maybe should look at it once every month, every quarter. Gee, does that change? Right. Upper right, power transistors. Yeah, they're happy. They're warm. They're paid to be warm. The thing in the lower middle, that's mostly reflections and just emissivity issues. That's shiny stuff.
Right.
However, you look at that, the right-hand strap is going to a coax where it's kind of bolted in with a nut and a compression fit on the inner conductor. And that's not making connection as good as I would like. And also you can see the threads on the connector there. A little bit of corona is giving you that heat effect. So I'm not worried about the J plug, I'm not worried about the strap, but I am worried about the connection to the transmission line. Maybe I should take it apart, look at it, see if I can't remake that connection.
Right.
So again, what is normal? What looks right? And
then motors on the right. Just another point. Does any of these motors look different from the rest?
Yeah. And that's so if you've got more than one thing, you're looking to see if they look the same as each other, assuming similar operating conditions. And if you've only got one thing, then you want to look for change over time.
Yep. And again, similar operating conditions are key. Is that one phase has something else on it?
Yeah.
Today,
Now, Keith mentions sometimes you don't need a thermal camera or sensor. You can just simply look at the discoloration of the transmission line to determine whether it's thermal damage. But,
absolutely.
you know, at that point, the damage has pretty much already happened too.
And it's great to have two things that are the same that you can compare. There's a tower in Miami. Two antennas are identical and almost identical in transmission and everything like that. You walk up to them, you touch one line, you touch the other, and they're different temperature. Something's definitely, you know, going on here, and that can raise questions. You know, if their numbers on paper are this, then they should be this in real life. So
in one case, the lines were different, but the transmitter output power was different. So okay, that makes sense. So it's again, think beyond the, oh my God, what is that moment to, okay, does this make sense or not?
Yeah. If I got 25 kilowatts in that line and 25 kilowatts in that line, they're both terminated by the same load. They should be pretty close to the same temperature, theoretically.
Yeah.
All other things being equal. Oh, and this was the one I was mentioning about the strobe flasher. And so I took a picture, obvious hot spot. Number one, don't pay any attention to the actual temperature reading because that's taken through a sheet of plexiglass. And as we discussed, you don't know what the transmissivity is. So how much of that's reflection and how much of it is real. The other thing, the thing I was taking a picture of, the hot spot's a heat sink. So you expect something bolted to a heat sink to be a little warmer.
And you can see the distribution of heat from that around the rest of the devices. And that device upper center, is that getting a reflection from the heat below it? Or is that in fact another active component that likes to run warmer because of its job?
Right. Now, over and above that, because you've got a soft spot for the old hollow state technology, you sent me this.
Yeah. So that's
glow FETs.
Yeah, glow FETs. And modulators, I believe, are on the left. I don't remember. Anybody remember RCA BTA 1R3? I haven't touched this in about a year, but there's a pair of modulators and a pair of final amplifiers. And I think the modulator's on the left, so the finals must be on the right. And that one tube, the third one over, it looks a little hot at that neck of the glass envelope, but it's hollow state. God knows what's going on. But,
well, and it could also be the angle relative to the other one and where it is, because again, like you said, with the gun sight versus the where you're aimed.
Yeah, and you can see there the gun sight there. This was just a beauty shot. Hey, that's cool. I'll take a picture.
So, yeah, Tim is taking notes on my use of glow FETs as a term, but I think you can credit. I think Chuck Kelly was the one that gave me that one originally. So there you go.
I like that.
I did mention resources, but before we get to those, so summary, top half was yours, bottom half was mine, and you mentioned again, I mean, it's one thing to have the tool and to have played with it a bit, but it's also really useful to know what you're exactly looking at and what impacts it.
If you don't have the time or the money, and mostly it's both, I guess, to go through a formal training course, you don't really need it to do the bulk of your jobs. Just go online and look at Fluke or FLIR or somebody legit's training videos and where they talk about these topics. That'll get you where you need to go. You don't need to be certified. With the reason for the certifications is if you're working for a power company or a manufacturing plant, or you're like us where somebody thinks you're an expert and they're going to make you testify. That's when, you know, level one is this is how I take readings. Level two is you can actually interpret, and level three is now you're responsible. And if you're not working for an industrial organization or a power company, you probably don't need to go through all that expense and time. So, you know, don't stress out about having to spend the money to use your tool. Go ahead and buy the camera that works for you. Talk to us, talk to other people who are using it. FLIR is pretty good if you can get through to a person about helping you out with problems. And they have all sorts, the FLIR and Fluke have things that can, the ultrasonic cameras, the gas detection cameras of different ranges and sensitivities. There's a lot of solutions out there for particular industries. So don't be afraid to contact the manufacturers. Some manufacturers are actually nice, Jeff, and they will help you. And
I should meet some of those people someday.
Yeah. So, go online and see what's there. Of course, you can tell online what's bogus and what guy you want to be. Rafael's good at finding bogus sites for me.
There you go. Well, we were going to say, among other things, after the previous conversation, but
I usually half the things I find on YouTube, how to build this, how to do that.
so some of those are highly entertaining.
With self-train and kind of take it around the house, and your spouse will laugh at you. And one interesting thing is I said, God, hey, there's fish in that aquarium. I wonder if they have any heat because they're cold-blooded. And I got a better picture of me reflected than I did any of the fish.
Yeah.
Just,
and I can just hear the "you dummy" comment coming from the back of the room at the same time.
yeah, exactly. But it's just, and we found when you have some insulation problems, and yes, indeed, the GFCIs are hot, and that's okay. They're supposed to be.
Yep.
So.
Right. The bottom half of this page was my hot takes: reflectivity, emissivity, and transmissivity, and all three of them have bit me in the tail at one point or another. Like you said, common sense. Does this look right? And if not, why not? So, Rafael, what's your I guess summary? What's your top thing to take away?
My top thing to take away is that just like the coppers,
there'd be a quiz.
it's never trust what the camera tells you.
Yep.
Right.
Question it. Because like I showed in the copper, it could give you so many different types of false ratings.
Even just the clear paint, and that really struck me because I've got a customer used to be one of our reps who would do a hardline install, and the last thing he did on every new install was go through and just take a Scotch-Brite pad, polish all the line up beautifully, get all the fingerprints off, and then do a coat of clear lacquer over it just to seal it so it never got fingerprints and always looked shiny and new. But at that point, like you said, it's going to throw temperature readings totally out the window.
But again, you get your Scotch 95, whatever the heck it's called, and put it on there, and now you got a reference. Utility companies or big installations will have a reference black stripe on the switch gear. So you don't need to go be reaching into the 480 volt stuff and put a piece of tape on something. It's already there as a reference for you. So there are workarounds.
Yep. And that's one of those things too. Let's see, speaking of references, I'll throw this up here in case anybody wants to grab a screenshot for the FLIR references. I mentioned the Delta, the drone related papers, which are really more related to thermal measurement in general, not specific to drones. So that's the very bottom link on that page. The infraredtraining.com is the link to FLIR's online and in-person training courses. Ed has put a link up in the chat for a YouTube channel on infrared training. So we'll trust Ed got that right, but if he didn't, I am very certain that either Gary or Rafael will let me know in very short time. So
well, I actually came from Rafael, so
there you go.
If there's anything untoward that something he picked up at the men's club, he referenced earlier.
But he's taking medicine for that now, so it's going to be okay.
I've heard there's an ointment. Anyway, on that note, folks, I want to thank Gary Cavell and Rafael Gonzalez for being with us today. I really appreciate your time, gentlemen. It's been highly entertaining and enlightening.
Our pleasure. And just guys, go out and play with the toys and learn as you go. It's fun.
And folks, I want to thank you all for spending the last hour and a quarter with us. Really appreciate it. And we hope to, let's see, not going to be around next week. The week after that, I'm on the road. And then I think through March, we're planning on starting some webinars on some NAB related stuff. So you might see a little break from the TTT sessions, but we'll see what happens. Just keep an eye on our social media and we'll let you know what's going on. Thanks very much. Have a great week. Bye now.